education, making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Gracing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
All right, what's up, everybody? My bad, it was a little delayed. I had some meetings that went late. Well, actually.
Oh,
I hate when meetings are supposed to be 30 minutes long, and then they turn into, like, hour and a half long meetings. Not fun. Oh, but I guess I am early for the rescheduling. I rescheduled it by 30 minutes. Yes. John's like, yes. Yes. Just started, John. Jack. Wow, Rescles, Roxy, Matham, Eric, dude, all the homies, dude. What's up, guys? Yes, I'm done teaching at UCLA, thank God. I still have to grade. No, actually, I take that back. I finished grading their final exam, but I still give them like a couple days to do corrections and like get more points back for their shit. So I will still have that for the next couple days, and then I got to submit like final grades to the registrar. That takes a little bit of time, but I'm not streaming anymore like teaching. I'm not teaching anymore. We're back to normal office hours. I might have the UCLA students might come by and ask some questions, but it's normal priority now with everything. Ooh, the chess champ logo on me. It looks nice, doesn't it? Yeah.
My name is Jeff.
Where's Jeff? Oh, let's change that, dude. We do got to give him an effect. Let's give him an effect. Let's give him an effect. Where's my fucking stuff? One sec. I think it's under roles. What color you want chess champion to be, Mathan? What do you want it to be, dude? You want it to be pink? Red? Okay. He wants it to be red. Alright, let's give him a gradient. Let's make it like red. I'm gonna make you red and pink. How about that? You're so cute. It's okay. He's red and pink there. There you go. He's pink and red. Oh, all right. Yeah, Sensation, you can always come up. What's up, dude? Present. Jeff is present. What's up, Sensation? I haven't heard your voice in forever.
Oh,
It's been so sad. So
What's
lonely.
up?
Said I haven't heard your voice in a while, dude, because of all the UCLA stuff I was having to do. He's like,
plebeians.
First order of business, yell the N-word.
That's not very nice.
5 minutes is fine. I did have a couple of the UCLA kids ask me, they're like, wait, are you doing office hours today? Like, wait, can I still get help? I'm like, yes, you can, but it's now going to be unhinged, and I'm not going to give priority to UCLA anymore. Because I'm done! There you go. Raspberry Pi gradient. What's up? Hello. Yes. Okay, cool. So yeah, that's the news. I need to set up a new streaming schedule because the streaming schedule I had was for when I was teaching at UCLA, so I might change it up a little bit. I will only be streaming though for like the next 2 to 3 weeks, because then I got to go to Burning Man, and that's like a week and a half of my life. So I would say that we're in like a fun little in-between period here before the school year really starts for people. But when I get back from Burning Man, that's when we'll go like full force into helping everyone out the school year, because yeah, that'll be like, I'll be back from that like September 6th, I think, 6th or 7th. Yeah, no more listening to what's on the exam. You guys are hilarious. Oh wow, there we go. Now we got Sensation without the hat. Sensation hatless.
And a skinhead.
And a skinhead. Okay, there you go. Have you been involved in some protests in North England?
No.
Oh no.
Emotional. That's not where my mind went.
I know there's some civil unrest over there.
No,
Well,
some
no, 'cause
American protesters that would.
Oh, is he
take him
American
looking like that.
protesters? No, I think the British do it too, right? Is British skinhead a thing?
Yeah, but it's
I feel like
different
it's
in
a
the
thing
US.
everywhere.
Yeah.
Because I mean, it came from the Nazis, so it would be.
No, it didn't.
Yeah, I don't think so.
I thought it did.
Do we have to?
No.
We have
I
to.
don't know. I mean, I don't know the origin
I don't claim
of it.
to be
It's
an
not like
expert
my-
on this material.
Yeah, it's not particularly something I dive into heavily.
Yeah, I wonder. I don't know if I feel safe like googling where did skinheads come from, because I feel like Google's gonna put me on a watch list.
Jamaica.
Jamaica. Oh, okay.
Just for the record, the YouTube comment.
Yes.
It says
Hello.
konnichiwa.
Konnichiwa. Hello.
Please don't.
So apparently it was the British mod. Oh wait, there we go. The British mods and the Jamaican rude boys of the 1960s. Working class youth in
What did I
England.
just say?
Yeah.
What did I just say?
But it is from England though.
Yeah.
Yeah, okay, interesting. Later shifts, and then apparently the far right took it up, as usual. Okay, cool, whatever. Always good to learn our history. Alright, nice. So yeah, we had a chess tournament on Friday. Congrats to Mathan for being the chess champion. That's awesome. And then, let's see, what else? So we'll be streaming this week. I will see if I can do another tournament-type gaming thing. Maybe we'll do some Fortnite on Friday. And then otherwise, just getting back into the regular schedule before the school year starts. So that's what we're doing. There you go. And yeah, chat works on YouTube. I need to go through, like, what's on the queue so far? There were so many things on the queue. Oh, man. Some of these are from 8,000 minutes ago. Yeah.
Immediate ban.
Immediate ban. No, it's okay. These are just things I just never got to, unfortunately. Let me remove some of the ones that we don't need anymore. I can remove this one. I remove this. Daddy's whatever, devious. I'll keep breasticles up because those are kind of fun. Or maybe I should just clear everything. I think I should just clear everything, actually. Let me just clear everything, because otherwise this can become like... Otherwise the whole thing doesn't really work. Here, I'm going to post all. Then I'm going to clear all. Give me a second. But yeah. That's all the news and updates. I'll make a big announcement in the server as well about other stuff going on. And there we go. Now the queue is fresh and clean. So if you want to submit something to the queue for us to go over, please do it. We'll do it during the stream. What's up, Sensation? Do you have anything you want to say?
Just quickly, did it automatically translate that for you?
No, it just says hello. Are you saying on my chat?
Yeah, because that's not what I said.
Oh, interesting.
He said hello. I said sop.
And it translated and it auto-corrected it to hello. You know, this is a thing actually. During my teaching streams, there were students that were saying I didn't type that. I think there's like an autocorrect that sometimes happens. Kind of weird.
In what way?
In YouTube, I think YouTube does like an autocorrect or like a.
Oh.
I don't know. You said sup.
Wow,
and
that's insidious.
That is really insidious. Wait, you said sup and it, because no, it did happen to some of my students. They're like, I didn't mean to say that, and I'm like, wait, what? And I always thought, I'm like, oh, is it an autocorrect on your phone? But you're saying it was an autocorrect within YouTube that did that?
Looks like it, yeah, because I wrote
Damn.
the chat.
What are they doing? The police state.
Well, no, it's so much more insidious than that, though. I imagine at some point you've actually read 1984.
I have read, yeah, of course. Orson Welles? Is that who it is?
Orson Welles.
Or am I thinking Orson Scott Card? I'm thinking Ender's Game.
Now I can't remember who wrote it.
Yeah, who wrote 1984? Somebody tell us. What's up, Rockover?
It was George Orwell.
George Orwell. Okay, I was
Yeah.
close. I was
Yeah.
or something. George Orwell. Thank you, Jeff.
My name is Jeff.
But the whole point in doublespeak was to undermine the meanings of the things that are being said.
Okay. Is this what we talk about?
They called it doublespeak.
Doublespeak. I need to reread that book, honestly. But
Basically, what Ministry of Peace was all about war. These are all simple terms, but then you'd say one thing and mean another.
is this kind of like when people are saying weird words on comments so that it doesn't like trigger like certain filters?
Yes,
Like,
exactly that.
They're like saying, well, that person got graped. I'm like, graped? What? Like versus peached or strawberried? Like what's going on here? I know what they're trying to say.
Undermines the point.
Yeah. Or like they won't even say the word like sex, they'll just say S. And I'm like, wait, what? Just say it. I don't understand, man, dude. Yeah, it's fucked up.
Oh no.
Ugh.
Because I mean, these words are supposed to have emotional reactions, specific emotional reactions.
Uh-huh.
If you like undermine the word itself, it's like I can't even explain.
It just leads to bad shit happening. Right? Can we agree with that?
It's certainly a road towards, oh, I can kill a guy and not really care because we'll call it unalived.
There we go. That's the other one. Yeah, unaliving. Yeah, it's so
We're
dumb.
kind of already at that point in America.
That's what I'm saying. I think we're already there.
Like,
That's unfortunate.
cops will pull up, see a shooting, and they'll just be like, probably gang violence. And then they just don't look into it. There's like, it's gang violence.
Yeah.
Is
There's
what
a lot
it
of
is.
that recently. Yeah, a lot of weird stuff going on. I will slime you. What the fuck is slime? No, I will slime you, dude. That's from my era, dude. Getting slimed. I don't know. There was also like a Nickelodeon thing where they would dump slime on people. It was like a humiliation ritual. It's another great one.
See, because sliming somebody usually meant just like saying untrue shit about them.
Right, like slandering would be to slime someone. You slander them.
Yeah, and so whilst that's still sort of weird colloquialisms, it still sort of makes sense.
Say dead ass. That's an actual word though. Dead ass. No, stop. So getting slimed. Does anyone remember this? I don't know. Let me see. Like, do we got like a GIF of this?
Yeah, I remember
Yeah.
that. Like,
Does anyone remember
on
this?
all
They
the
just be
ads.
like, oh, let's just slime these kids, dude. And you look at this and it's like, it's kind of like bukkake, honestly. Just like, this is kind of weird. But then again, Nickelodeon was up to like all sorts of like sus shit during these days. Anyways, yeah, okay, I digress. All right, let's see. Let's go help some people with some math and science homework. Looks like we got some stuff on the queue. So let's kick off the stream and help you guys out. Cool. All right.
That's dope.
All right, welcome to Actual Education Office Hours. My name's Dr. Gold. The return of the stream that helps you out with math homework, science homework, all sorts of fun stuff. Let's go live on TikTok. You can't talk about Winnie the Pooh anymore. All right, let's see. And then, yeah, let me get this chat working on this one. Okay. So, again, if you want to submit a question to our stream for us to go over, the way to do it is go to this website, www.actualofficehours.com, and submit a screenshot of what you want. And the longer that your question is in the queue, the better chance you have of it getting selected, and then we'll also like kind of spin randomly for some people here. One second, I need to fix my camera's brightness is off. Dude,
Nothing happened on June the 3rd, 1989. Nothing.
June the 3rd, 1989. Is that the fall of the Soviet Union? Was that June 3rd?
No, that involves a incident with
A man
with a
standing above a tank.
rectangle that is a special case of a rectangle, and some tanks.
Oh, okay. Oh, that one. Yes, that one. A special case of a rectangle. All right, let's see if the. Let me see if the whatever the. Dude, look at these 8 out of 10, 8 out of 10, and then Breskles with the 2 out of 10.
Although what's crazy is that first one was a 7 out of 10, and then I cut off like 4 pixels on the right so that I could resubmit it, and then it changed to an 8 out of 10.
That's too funny. I wonder how it's detecting it. I need
it.
I need
same thing with that other one. It used to be a 4 out of 10, and now it's a 2 out of 10 by just chopping off some like white pixels.
Well, this is just a matrix, of course. Like, let's look at what like it classified it as like it's a matrix notation. Yeah, sure, great. It's just like identify the matrix. Of course, duh. That's a 2 out of 10 question. Yeah. Now that I have more time, I'm gonna go through and maybe like recode this a little bit because the AI stuff has improved significantly since I last edited this, which was in May of last year or this year. Sorry. Be cool to see what we can do with it. All right, let's go spin and choose a winner. See who we're gonna get.
Let's go gambling!
Bow, 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 bow. There you go, Breskles. It's the first one. You're 8 out of 10. Partial differential equations. Laplace. Oh, Laplace. My sweet, sweet friend, Laplace. So let me kill all this. We don't need any more of this anymore. Okay. Cool. All right, Laplace equation. So I have a boundary. Is this dude, we need to work on your handwriting, dude.
Hey, all I'm saying though,
you really
is
gotta work on your
handwriting. Clear handwritten on that last one.
No, fucking bullshit. It did what?
Yeah, it said clear handwritten.
No, it said readable. It said it's readable.
Oh no, I'm talking about the other one. The other one.
Oh, the other one? Oh, the other one said
it said it was clear.
Yeah, that's okay. You're right. That one is clear. Okay, cool. All right. Okay. Anyways, there we go. So u is f of x, I guess, on this boundary is what we're saying. Okay, cool. And then it's of dimensions a, b. U is equal. Is this 0 here or is this d? What is this?
That's 0.
This does not look like a 0. My brother in Christ, dude. This does not look like a 0, dude. What? This is like me saying that, you know, my alphas, which we know my alphas are just CXs at this point, right? Or I don't know actually. I actually don't remember how I do these. Whatever.
Yeah, it's
Okay.
CXs. I was asking Zach if it would be cruel if I did like a 4x4 like determinant of a matrix and it was all just C's, X's, and alphas.
That would be bad. Okay, this is a 0. Bing Bong says, "Yo, I started betting. I started sport betting. Now I'm kind of broke. How do I make it back?" Bing Bong. Bing Bong.
That's so racist.
Or I guess get better at sports betting.
I started sport betting. Now I lost all my money. Dude, classic Bing Bong, dude. What? That's the whole point of all these markets and stuff, dude. Is make you lose cash.
Not if you bet correctly.
Not if you what correctly?
Not if you bet correctly.
Correct. Yeah, if you bet correct. But usually they're set up in a way that the house always wins. House always wins. Yeah. How do you make it back? Stop betting, Bing Bong. Don't do it anymore. Bing Bong. No. Just chill in the sport betting. Do other stuff. Save your money.
50 quid on 0.
Roulette wheel or
roulette. Stop.
I won 50 quid on 0 one time.
You can. People do win. It's why they keep coming back. What level math is that? This is partial differential equations, which is probably like a upper division undergraduate class.
Yeah,
Maybe
it was
you're
a 4,000 level course for me, and then I did this question on the 5,000 level course.
Crazy. Okay, so we're saying the second derivative with respect to x and with respect to y sums up to 0. The first derivative at 0 is 0. The first derivative at d is this d? Is this d? This is d, right?
That's also 0.
Oh, Jesus, dude. Oh, wait, what? No. This is the same statement, though. I'm so confused.
Oh, no,
here.
that's A. That's A. That's A.
Oh, this is A
Okay.
now. Oh, okay. Okay.
yeah.
That's dope.
Okay, this is A. Okay. And then at 0, and then at x comma b is equal to f of x. And this is your boundary value position, I guess, yeah. Can you please provide a proof of the Collatz conjecture?
Collatz
That's fable.
conjecture. No, fuck off.
Yeah, no. It's that or the Riemann hypothesis, dude. I always get like at least one of those. There's always someone ask me that. Okay. Yes, and you're right, Jeff.
Go
You
to
are
the
trading
library,
against
get
other
a
people.
book.
Yeah, go to those dying things called libraries. They're now homeless shelters, basically. All right. So how do we start this one? I'm gonna assume we're gonna use this to like try and write some equations out and derive things.
Yeah, we want to start with good old trusty separation of variables.
Nice. Okay.
Which is
So
what we
I have
pretty much everything.
uxx plus uyy is equal to 0, and that's the same thing as saying the second derivative of u with respect to x plus the second derivative of y, of u with respect to y is equal to 0. So am I going to come up with some new function, u, which I'm going to say is like big X of x and then like big Y of y?
Yeah.
Nice. See, I remember this. Slowly I will learn how to do PDEs. Okay. So once I have that, okay. So, wait, this is going to have a y in front of it, and this will have a big X in front of it, no? Right, and sorry, this is equal to 0.
Yeah, pretty much. You're gonna have x double prime y, and then y double prime x.
Exactly. Okay, yeah, cool. Yeah, so this will be big X. Which is going to get kind of annoying to write. Double prime, and then there's going to be a big Y attached to it. Because that y is just a multiplying constant. And then plus big Y double prime and then big X. And then this is going to add up to 0. So I'm going to move one on the other end, move the other on the other end, and I'm going to divide. So is this going to be X double prime over X?
Yep.
Is equal to negative Y double prime over Y? I think so.
Mm-hmm.
Okay, cool.
And that's a negative lambda.
There's a lambda? Why is there a lambda?
No. So remember, right? Because one's a function of x and one's a function of y, and they're equal to each other. The only possible way that they could be equal to each other is if they're equal to some constant, and we call that negative.
Separation constant. Yeah, the separation constant. So.
Technically, it's an eigenvalue.
Oh, I see. Because you're saying that. Wait a minute. This is only things. Derivatives with respect to x. That's only.
Yeah, because
things
remember it's.
So
x of x is a function of x, and y of y is a function of y. And so
Right.
the only possible way that they could be equivalent to each other
is if they're not
would
equal to
be
things
if
with
it
x's
was
and
just a
y's.
constant.
Right.
Mhm.
Got you. Yeah, they have to be equal to. Well, this is just a constant.
Because then you gotta test like different cases for lambda, right? Like lambda is greater than 0, equal to 0, blah blah. You know.
Yeah.
Okay, we'll get to it.
Usually you want to say negative lambda. Just
My partial
it's
derivative
computationally
deltas look
easy.
ugly, dude. Someone's yelling at my fucking partials looking bad, dude. If anything, we need to yell at this dude. Chill, user. Let me one sec. And can a 3-dimensional frequency table be used to display more complex data sets? I don't know about that. And then Datsu says, I skipped Calc AB to Calc BC. What topic should I learn with a 2-week time frame?
I did that.
Well, anything you learn in BC is just AB but accelerated. So you're not missing anything skipping from AB to BC. It's just gonna happen faster.
I think BC skips like limits.
No way. You have to do limits in BC.
BC is basically the equivalent of Calc 2.
No way.
Set up, like when I took it, is AB is Calc 1, BC is Calc 2, and CD is Calc 3.
No, chill. Y'all need to chill. Y'all need to chill, dude. I don't believe that. I agree that you guys took it earlier than I did. What is it? AP Calculus.
It's on the exam, but
yeah, there you go.
Teachers don't.
People are telling me that BC doesn't skip limits; it's just accelerated. I agree with that. Also, I will say in pre-calc, you tend to cover a little bit of limits at the end, which is why maybe they don't cover it as much. And here you go. Yeah, we can look at the syllabus, dude. I'm pretty sure. It
has limits and everything. Most teachers just don't teach it
because there's always an AB subscore. There's an AB subscore to it.
Yeah.
Right.
And teachers don't teach it again if you're taking a BC class, because they know that you already know limits and derivatives. They just start like.
Oh, you're saying the instructors assume that you...
generally instructors like teach it like 1, 2, 3.
Oh, that's fucked. Yeah, no, I when I took this, we just took straight BC. We didn't take it. We didn't take AB. It wasn't expected to take AB. You weren't expected to take AB and then take BC. You just did AB if you wanted like a more chill pace and you didn't want to cover limits and series and not limits. Sorry, you didn't want to cover like series and convergence shit. But BC you took if you wanted a fast calculus course, and then they still taught everything.
Like at my school, the teachers, like the BC teacher, doesn't teach everything. Like they don't teach like finding extrema and like all that. That's the work.
That's stupid.
Oh no!
You shouldn't be expected to take AB in order to take BC.
I know that is true,
to me that seems really dumb. Like the BC teacher should just.
I kind of liked it the way it was set up there, because you got like a full course on like all of the standard like differentiation and integration, and then BC was like dedicated, at least the way it was set up where I went to school, it was pretty much dedicated to kind of like focusing heavily into like series and like more advanced methods of integration, because those were obviously things that were more challenging to a lot of students. Even, at the college level, a lot of kids struggle with series.
They do. Yeah, that's what Zach's whole thesis was on. Okay, but let's solve this question, because otherwise I'll never get this done. Okay, so I'm here.
Negative.
What do I do now? Negative
lambda needs to be it doesn't particularly matter, but the computation is nicer if you make it a negative.
Cool. All right, let's say it's equal to negative lambda. Great, cool. All right, then do I just solve for each one?
Yeah.
You have two cases.
Well, okay, so what I'm going to do x double prime over x is equal to negative lambda. So, I don't know, I can put that over there, right?
Yep.
Cool. And then I just integrate twice? This is dx dx.
You'll want to do a characteristic equation, or characteristic polynomial.
Characteristic?
Yeah, so what we're going to do is we're going to call lambda alpha squared.
We're gonna call lambda alpha squared. Okay, fine.
Wait, why do we do that? Because like, don't you have like x double prime plus lambda x is 0, and then y double prime minus lambda y is 0, and then what I do is like case 1 is lambda is equal to 0, so then that's just like x double prime is 0, and then you integrate it twice.
I think the reason is this is the wave equation. Like I already recognize this. I know this is the wave equation. Yeah. Where I just get that like x is going to be equal to c1 whatever, like sine alpha t, right?
Yeah.
Plus c2 cosine alpha t, and that encapsulates all the lambdas. Yeah.
Yeah. It's kind of that. So the idea is this technically is what's called a Sturm-Liouville problem, And there's a
Stern
whole
Louisville.
class of like, Sturm, STURM.
Sturm Louisville. Okay, cool.
It's like a whole class of problems, and as you like do other research in those problems, there's a lot of very nice properties about these like certain class of problems, having to do with like the adjoint of a differential operator and finding like Green's functions and modified Green's functions on like Sturm-Liouville operators. They happen to work out relatively conveniently. If I remember correctly, all Sturm-Liouville operators are self-adjoint, which is a helpful property for finding inverses, and there's some other properties with it. But generally what it comes down to is if it's negative lambda, when we have an equation like x double prime plus x equals 0, the solution space of that is a vector space. And so when we're solving by saying alpha squared is a eigenvalue in that solution space, and then we know that sine and cosine are what's it called? Are our eigenfunctions for the second derivative operator.
Okay,
so
wait,
by
actually,
creating a.
I was gonna say when doing this. Wait, sorry, this is an alpha t though. This is a mega t, you know?
That's
sorry,
if you
or lambda
choose
t.
B omega, but we said no. It's alpha.
It's still alpha?
Yeah, because if we're gonna say that lambda is alpha squared.
Lambda is alpha squared.
Yeah, so then you get.
It's like d squared, right? D squared x dt is equal to, I want to say it's omega squared. Ah, you're right, it is. Right, it's omega squared x. Got it, got you. And then, yeah, okay, I remember how that works. Okay, cool. All right, so that's x. What do I do for y, though? Y is going to be a positive, though, so that's kind of a problem.
Yeah, so we're going to solve that one, too. It's not going to look like two trig functions. We're actually going to use hyperbolic trig in this case.
Hyperbolic trig. Oh, no. Oh, no, dude.
Sine.
Okay.
Hyperbolic sine or no sine? Yeah.
Okay. So this, I'm gonna use the same substitution, saying it's alpha squared, or no? I think we want to. Right?
Yeah.
Okay, cool. Okay. Cool. Alpha. Yes. Great. Then, there's a known solution for this, or?
It's basically the same thing. So in the same way that we can say x is equal to c1 sine of alpha t plus c2 sine of alpha t, with the exponential functions, they're also eigenfunctions of the second derivative operator, just like e to the x's. So we can do the same thing, right? We're just creating a basis for our solution space.
Oh, but this would be like, like C3, C4, right? Gotcha, cool, dude.
Can you not say C of n? No, wait, no. Cn like hyperbolic sine of n pi y over a, or is that not?
Mm-hmm.
I think we're probably gonna get to that when we do the Laplace transform or something.
You just write in a. Normally, I write a subscript n just to clarify that it's.
Yeah, because I didn't do no alpha squared or anything.
Use Euler's identity.
Pops up later.
Jeff's like, use Euler's identity. Use the Zach equation, dude. Use the Zach equation.
Yes. Use y equals mx plus b.
Okay. All right. What do we do next? I got my X.
So now we want to evaluate our boundary conditions.
Oh, okay. Yeah. Oh, yeah. Let's go get all this shit, dude. Hell yeah, dude. Let's go get this. Pull it down.
Oh,
okay.
You did it after.
Evaluate boundary.
Yeah, because then the m pi comes from our boundary conditions.
Yeah, because I did it first. I didn't do like alpha squared or anything. Once I got the ODEs, I just, because the boundary conditions on the left and right walls are homogeneous, right? So, yeah. So which means that the first derivative x of 0.
Wait, so u of x is gonna be yx prime though, right?
Yx.
Yeah.
Because I said u is equal to this. So if I take the derivative of this comes, and then this is a derivative.
Yeah.
Okay. So that's unfortunately going to be all this mess, right?
It'll save you some time if we first do the just U and X.
Which one?
Not the if you do the boundary conditions.
Oh,
for
do
just
these
U,
boundaries instead of doing these? Yeah,
Yeah,
smart.
that way you'll have
Gotcha.
constants that are going to go to 0, and then that makes evaluating those conditions
Okay.
much easier.
U of x comma 0 is equal to 0. Okay, so that means that when x is x... Wait, I put this as alpha t? Sorry, this has been alpha x, not alpha t, right?
Yeah.
Gotcha. This is like big capital X. This is little x. Then this is big capital Y. This is little y. The physics in me just wants to put t everywhere. Cool, and this is y. Okay. So then, u of x comma 0. So that's going to be...
That means that
C1
0 is 0.
sine of alpha x plus C2 cosine alpha of x. And then I'm going to put in 0 for y. I'm guessing sinh of 0 is 0, right?
Yeah.
So
It is.
just times C4? Okay. So that tells me if that's true for all x, then either like C1 and C2 need to be 0, but that would be trivial. Or C4 is equal to 0, right? So C4 must equal to 0. Yay. We're getting closer. Okay. And then let's do the next one. U of x comma b is equal to f of x. Well, that's not really going to help me because I don't know what the fuck f of x is. Oh, f of x is u? What? Excuse me? Oh, no, sorry. You're saying u there is equal to f of x. Oh, u at the boundary is equal to f of x. Okay, so I don't think this boundary condition really helps me at all, does it?
Not a ton, no.
Yeah, I don't think it does anything. Okay, unfortunately. All right. So now I'll go do the derivative. So u prime, whatever. U of x is going to be equal to big Y x prime. And we already said C4 is equal to 0. So that's going to be C3 sinh of alpha Y.
And you don't even really need to consider the sinh term. In this case, you can just focus purely on the x of x, just because if that sinh term is 0, then it doesn't really matter.
Right, yeah, if C3 is 0, then we literally have nothing. Okay. But then, okay, so this at 0... Yeah, again, I don't really care about this because this doesn't depend on x. But this is going to become C2. Oh, just C2. Okay, cool. And so that tells me that C2 must be equal to 0. Great. Okay. And then the next one says that A. Oh, so that's going to put a restriction on. Okay, I see what's going to happen. This is going to be equal to this. And then it's going to be times C1 sine of alpha A. And that's equal to 0. So that means that alpha A needs to equal to n pi. Right? Okay, cool.
Yep.
So,
which gets us alpha as n
it gets
pi
us alpha.
over
Okay, great. Okay, so alpha's... Oh, this is cool. Yeah, and I always see this with, like, Fourier shit and stuff. Okay, cool. Okay. So, now, so far, I have that big X is going to be equal to C1 sine of n pi over ax, and then that big Y is equal to C3 and which one was C3? Sinh of n pi a times y. Okay, great. Cool. Easier to say dx of x dx evaluated 0 is 0 since y of y can't be 0 for all values y. I agree with that. I agree with that. Yeah. Yeah. C3 can't be. Right. Okay. All right, so I've got this. So that tells me what U is. I think the problem is I don't have C1 and C3 though, right?
Yeah, but you can evaluate those by plugging in your other conditions.
Okay. Are we done? Is this it?
Pretty much. We just need to express it as Fourier series.
Oh, okay,
this
just that.
point.
You know, we just need to do that. We just need to do that. Okay. Okay, so that's U. And then you say I want to express each one of these as a Fourier series?
No, so see how they're all dependent on n? By the superposition principle, we can say that the whole solution.
Oh, sorry. These are
is gonna
different
be
things,
the
right?
sum
Sorry,
of all.
this is n pi x and this is like m pi y, right? Like these n's and m's can be different, yeah?
No, they're the same.
Oh, they are the same.
Same n. Yeah.
Do they have to be
they're
the
coming
same?
from the same constant. Yeah, they're coming from the same constant.
Oh, okay.
Because we're saying that we restrict alpha A has to be n pi, which means that alpha has to be n pi
okay.
over a, and since they're both equal to negative lambda, that gets us that they both have to be equal to negative n squared of I squared.
Got
over
you.
a squared.
1 second. Why is my mouse not working? Dun, dun, dun. 1 second. Let me turn this off. Sometimes my mouse plays with me. There we go. Oh, now it works. Okay, good. All right, so what's next step? Someone said just add a sigma, but why mere models? Why mere models? What do I add with the sigma? Sorry, did I just put a sigma out front? Because it has
also,
to be for
I
all
think
ends.
I want to say it should be the cosine term, not the sine term.
Should it?
Oh yeah, I see what we did. It's because it's supposed to be x prime, and you just
Ah, you are so right.
so
yeah.
then the
I did
sines and
this.
cosines would flip
Right, this
and
should have been
C1
cosine. Yeah. This should have been cosine. Ah, okay, so wait, so this should be all the odd ones then, no?
No, it's still m pi a.
Because
you
of
would
this?
get that you would get C2 is equal to 0. Or sorry, let me see.
Wait.
I'm verifying that I didn't write my C1 and C2s differently. But it should be
I see.
cosine.
Wait. U of x. I see. I didn't do the derivative of x here. That was the issue.
Yeah.
So this should have been C1 it just changes this is just C1 cosine.
Mhm.
And then this is C2. This is minus sine. Yeah. What's up, derivative? Been good, dude. Pretty busy this summer. I was teaching a super fast physics class at UCLA, which was like kind of wrecking me. I see. Okay, so then this is C1. Right? Okay, so C1 is equal to 0.
Mhm.
Got you. Okay. And so then this would be...
Pretty much nothing changed. It just becomes the cosine term.
Yes, okay. And then we're going to say that this is n pi just to kill this, right? Okay. That's fine. Got you. Okay. Wait, no, C1 0, sorry. So this is C2 cosine. Got it, okay. Oh no.
Someone said that exclamation mark makes me uncomfortable.
I know, dude. This is what there's a whole Reddit on this. What's it called? Unintended factorial or something?
Yeah.
Yeah, it's a funny Reddit. How like exclamation points would make things like really, really bad. Yeah. It's meant to keep you on your toes there, Undercell. Okay, so sorry. This is good. What do I have to do next?
So we're just gonna pretty much literally just basically throw a sigma on there. So we're gonna call it the sum from n equals 0 to infinity. And we're gonna combine C2 and C3.
Just call it
into
CN.
one coefficient.
Yep.
Yeah,
I agree with
and
that.
what we're gonna do is we're gonna end up calling that the Fourier coefficient.
Okay. And then this is still cosine n pi over ax. Sinh n pi over ay. Googleplex. Exclamation point. Dude, that would break the internet, Jay. Don't do it. Okay. Can I rewrite this as something cool?
So what you can basically pretty much all you can do from here is you could re-index it from 1 to infinity and add a term a naught plus b for that first initial term, which is what we do a lot for the cosine series. Other than that, it's represented as a Fourier series, and that's our solution.
Cool. Let's just leave it like this because I don't want to write any more things. Yay! Good job, guys. We did it! We did it!
Well done! Well
Let's see how long that took. I'm curious.
Breasticles, you should check the chat.
Yeah, I was looking at that right now.
Alright, let's see. This was... So, Resticles. I like that. I needed less help solving that one this time. I'm starting to get it.
One day you won't need any help.
Yeah, one day, dude. One day.
Fucked up.
I look fucked up. Dude, I say that to myself all the time. I look at myself in the mirror, and I'm like, dude, I look like I've been through the ringer, dude. What happened in the last 3 years? What happened? You got sunburn or what? What happened?
Yeah. It's
You went out to the
nice
sun or
crimson colour.
what happened? You went out in the sun or you beat someone up? What happened?
Yes.
Yes. The answer is yes.
Oh my
Oh man.
fuck, man.
This is the north of England. I'll probably kick 3 people's heads in this week, so.
Alright, that one took 30 minutes. Not too bad. Estimated time was 20 minutes, so did alright. Alright, let's go see what else we got on the queue. Any other fun questions? Jack has answered. Thank you, Jack, for finding the stream. Good job, Jack.
Yeah.
And Jack, just as a little hint here. So anytime you have a question here, you can also click the upvote button here. And that'll give you a higher chance of getting picked. Yeah. Okay, cool. Alright, let's go spin a winner. See who's gonna get it.
Let's go gambling.
AFG! Okay, AFG. Combinatorics. You're gonna hurt me, dude.
You can try it. I've done it, but it was fun. It was fun, so that's why
It was
I
fun.
put it in the queue.
We like fun. Actual education. What can one do with a BS in nuclear physics? You can do a ton of shit, dude. What? Nuclear physics is a very, very, very applied field. Yeah. Yeah. I mean, don't do any drugs because you won't pass the lie detector test. But
Oh no.
yeah, you can do a ton of stuff with a BS in nuclear physics. I feel like any of the national labs would take you in a heartbeat. So that's like Los Alamos, Lawrence Livermore, Sandia. There are a bunch of labs that are part of what's called like the NNSA, National Stockpile Stewardship, NSSA. I don't know, whatever. But yeah, basically the U.S. has a bunch of nuclear weapons, and we need ways to make sure that they still work. And so people with those degrees can go do that. Yeah. Have you guys learned about constructionist math? I have not. I don't know what constructionist math is. And then I think someone else asked what my thoughts were on AI solving all of the math conjectures lately. I think it's pretty cool. I don't know if it really represents advances in knowledge, because I think most of the things it's solving are just counterexamples, which I believe it's just like...
it's only been counterexamples.
It's just
I don't think
counterexamples.
It's actually proved anything new.
Yeah, it's not coming up with new knowledge. It's just brute forcing them.
I saw like Claude solved the hardest exam in like perfect score in like 30 minutes or something. I don't know.
It's probably because it sees the answers somewhere else.
Oh yeah.
Yeah, that's because those are like well documented.
Those are well documented. It's well published. Yeah, the AI doing like frontier, like new research. That's where this gets tricky.
Yeah.
So.
Which brings me to the obvious point.
Yes. What's the obvious point? It's not intelligent.
Well, it can't think. It can't think for you. So when it comes to the cutting edge stuff, it can't do anything new. And then, how can I put this? Fucking idiots, children, using AI all the time will learn nothing to get to that stage.
I agree. I love this quote that they say AI is just going to make a bunch of mediocre people like retarded, and I totally agree with that. I think it's going to drastically gut out the intelligence of mediocre people.
I think it'll turn university students into retards.
True, that too. Well,
it's already ruined shit posting.
It's already ruined.
There's not even any like. There's not even any like.
There's no new copy pasta
anymore in shit posting.
Oh
yeah,
man!
Like people used to shit post, they would put some effort into the shit.
Yeah,
post.
I
That's why
remember.
It was funny.
Remember when the memes had quality?
Now it's just like there's no effort behind it. It's not a good shit post anymore.
Yeah, it's not quality copy pasta. You don't think AI will solve a Millennium Prize problem? Not right now, Sways. Maybe in the future. I just think all the hullabaloo that people are having about whatever, like AI has solved like 6 math conjectures compared to the usual average of 1 or 2 per year. It's mainly just because it's their counterexamples, and AI is just getting really good at brute forcing things. So, I mean, you could also argue that that creates a lot of problems for like cryptography and stuff, because all sorts of, cybersecurity stuff eventually can be brute forced. So, take it as it'll be. But okay, let's try to do this one. For a permutation, sigma is sigma 1, sigma 2, blah, 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 all the way up to sigma 10 of 1, 2, and 10. So, what the fuck does this mean? What does this notation even mean, first off?
So, I mean, it's asking us to find t equals the sum 2
no,
to
but
the...
What is sigma? Like, is sigma an array? Is sigma a series of numbers?
I don't know. Sigma is just, it's the permutation.
I think it's just an N.
Ooh. I think sigma represents 10 things being arranged in some order. That's what I try to do on this stream all the time. Is I hate when like math fucks start like putting like really complicated ass like language to things. I'm like, just dumb it down. Like what is this? And I think it's there are 10 elements, right, in sigma, and the arrangement of them is a permutation. Is that what we're saying?
I mean, okay, so like sigma is a permutation of the numbers from 1 to 10, right? So it acts as a function that reorders like the set you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That set, the notation sigma of like I refers to like the number located at the ith position within that specific rearranged sequence. So like, do you get what I mean now?
Okay, kind of. I like to put things into like simple like computer science
sigma
terms.
1 would just be like
the first element.
If you chose the first one to be 10, then sigma 1 would be 10, and then if the second element was
okay, so it's an array.
It'd be 3.
It's an array.
Yeah,
but then they say of 1 to blank 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 10. So is that saying that the numbers can only be 1 through 10, or they could just be whatever?
So you have this set, the 1 through 10 set, and then basically you're rearranging it using the sigma function. So the sigma function basically rearranges the set, and the sigma of I just gives you the position. Like if you do sigma of 1, that gives you the first position of the new set, the one that's rearranged.
Okay. So sigma is just like some permutation of this. So this is like, I don't know, we could say like sigma sub 1. And then like sigma sub 2 could be...
Yeah.
I want to say like this, right? But then, for instance, sigma sub 2 of 2, that would be equal to 3. Because then that points to the second. Okay, so now this makes sense.
Yeah.
Yeah, that points to the second element. Mathematician, what's up, dude? Naroski, thank you. Naroski's always great. Naroski, what's up, dude? Here's a way to understand it. Write a sigma as a matrix of 2 by 10, 2 rows and 10 columns. The first row is 1 to 10. The second row is a permuted set. Yes.
I mean, for this problem, you don't want to do that, but yeah, sure.
Yes.
You can see it like that.
And Bruce, do you do chemistry? Yeah, I tutor a lot in chemistry. Yeah. If you found my my YouTube, you should see that like I have a whole series of videos on like chem tutorials. Wow, Sam's back for 51 months. Welcome back, Sam. What's up, my guy? Nice. Krishna, you got 3rd place in chess. Why were you not competing in our chess tournament, dude?
Oh no.
You could have gone for the prize, dude. Matham ended up taking it. Oh, I think it was like too late in your time zone, right? Yeah, because you're in India. Okay. All right. D of sigma is the number. Okay, so now we have another function, which is saying the number of indices I where. Oh, it's increasing? No, it's decreasing. Right? Because I'm saying the ith index is greater than the ith plus 1 index. So we want to know the number of... Okay, so for instance, d sigma 2, that would just be equal to... that would just be equal to 1. Because there's only one case of the element before being greater than the next element. Yeah?
Yeah, it's called a descent. It's basically just like a step down counter. So you look at your row of numbers from left to right and then count how many times like the number is bigger than the number immediately to its right. So
the funny thing about that is that like, nowhere in this problem did they say descent.
Yeah, I mean that's
nowhere did they say like it was going down. Yeah, I know. I get it.
Yeah,
like if you understand math terminology and stuff, this all makes sense. But to the average person, they would look at this and be like,
"Oh no,
this is like Chinese, dude. What's going on here?"
So here,
I get
Dr.
it.
Cold, if I give you an example, like let's say you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So no number is ever bigger than the one after it. So
right.
So D is equal to 0. But if you have that reversed, so you have a 10, 9, 8. So every single card is bigger than the next one. So, you know.
That would be equal to 9?
That would be equal to 9. And yeah.
Right, because the last element can't be bigger than the one after it.
Yeah, and
there
what
is
is
no
T in
element.
this case? Like, you find its D, and then you calculate 2 to the power of D. So if your D is 3, then it's 8. You know what I mean? Yeah.
Number to the left is greater than a number is greater than a number to the right.
So now imagine you lay out like every single possibility of those 10 numbers. They're exactly 10 factorial different ways. So you calculate the points like 2 to the D for all like 10 to the factorial possibilities, and you add them all together, and that giant score is T.
And then I want to divide it by 1,000 and find the remainder.
Yeah.
oh no.
But like, why? Why would I ever want to do this?
I don't know, it's fine. I mean, if you solve it,
It's just like, why?
you
I
just
get
wanna
it.
see the
Math puzzles are fun. They're fun. I might ask for the solution in like 5 minutes.
Okay.
Yeah, let me
I'll
just
put it as a spoiler.
Okay, put it as a spoiler for me. Because, yeah, 10 factorial permutations. Permutations is something I always like wanted to get better at. It's like a weird way of thinking. T for a string of 2 is 3. T for a string of 3, it's 13. And for a string of 4, it's 75. But I'm not sure what the pattern is yet. T for a string of 2. What do you mean a string of 2? Oh, I see. You're saying that if I only have 2 choices, if sigma can only have 2 elements in it. Yeah, got you on the set of 1 to 2. Yeah, okay. This is always so Fembox has a good idea. So like a good attempt at this is to think about something simple and try to see if there's a pattern. And I assume that I can't have repeat numbers, right? Is that true?
Yeah.
Okay. So, let's say.
And that's how I did it. I don't, because the problem doesn't say that you can't have repeat.
So if you have the set of 1 to 2, then the only possibilities you can have is 1, 2 and 2, 1. And so, in that case, d sigma here is equal to 0. D sigma here is equal to 1. And then the sum of those, yeah, is 2 to... So it's equal to 3, right? So then sum over sigma would be equal to 2 to the 0 plus 2 to the 1. Yeah, that's cool. Well, I want to see if there is a pattern.
Oh, yeah, there is.
A permutation is a rearrangement, so nothing can repeat. Cool. Great. Okay, cool.
Oh, okay.
And I get it. Okay, so and there are yeah, 2 factorial, I guess, ways. Yeah, 2 factorial perms. Right? Because yeah, if you had a set of 3 things, then this is 3 factorial perms. Because you have 3 choices for what the first number can be. But then once you've picked a number, now you only have 2 choices for the second, so that's times 2. And then for the last one, you only have a single choice left, which is times 1. So that's 6. I don't know if I want to go through and rewrite all the permutations of 1, 2, 3. Yes, it'll get ahead quickly. So sometimes this divide by 1,000 like helps us out as like a part of simplification. I think I want to come up with like an equation for how to determine how many times I can have decreasing things happening. Huh.
There's something called Stirling numbers.
Yeah, see, I have no clue what a Stirling number is. Stirling numbers. Oh, like n choose k? Or no?
Yeah. No, I mean, not n choose k. I mean, how do I explain Stirling number? So, like, yeah, for this problem, we would want to use the second kind formula. So, I mean, yeah, what it says there, which count the number of ways to partition a set of n elements into n k non-empty subsets. Do you know Eulerian numbers?
Nope.
Okay, so you need to know that first. Yeah, it's fine. I mean, if you don't, like, what is this?
Yeah, if I don't speak the language, I can't talk this. Yeah. All right, let's just go look at the solution. It's okay. I appreciate you setting like cool problems. They're cool, but yeah, I know my limits. I know what I know, and I know what I don't know.
I mean, you're not a math like PhD student.
No, I'm not a math PhD student. Yeah. All right. Use the identity for Stirling numbers.
The second kind, the one that was on Wikipedia.
N choose k of x to the k is this. Solve at n equals 10. K factorial.
Basically, I did the same thing. I came with a formula and then I just added them and then mod 20. Also, that thing is not n choose k. It's like, so n choose k would be like rounded parentheses. This is Eulerian numbers. So like it represents a number of permutations of length n that have k descents, and descents is what like I explained earlier.
By the rings.
The rings of power. Well, Femvox has done something here. Let's see what Femvox has. Let's see, Fem, what'd you do? You did n equals 4. Whoa! Good job, buddy. So you did all the permutations of 4. And... okay. Right, so this has no... oh, and then this is the 2 to the n. That's what this is. This is your 2 to the n column. Cool.
There's I think n equals 4 is the max you can go by hand. Maybe n equals 5, but after that, it's like... how do you
Can go by hand and are willing to go by hand are two separate things.
Oh no.
Yeah, anyone can go by hand. You could do this by hand if you really wanted to. It would just take forever.
Yes, but
I don't want to do 5.
Oh no.
Okay, well, alright. I don't understand what this is, but cool. I'll post a solution at least if anyone wants to learn about storing numbers and stuff.
it's fine. There's no one interested in this. No one's gonna look back to this.
I don't think many people in my Discord will, but some people in Zach's Discord might. Yeah.
Yeah, post it there.
It's cool. Again, AFG, it's cool that you're interested in all this high level math stuff. And it's awesome. You just need an outlet for it. And like
Yeah,
you need like a math club. Like where's there a math club?
near me.
Doesn't even need to be near you these days, man, dude. The internet's infinite, dude. You do so many things.
And on the internet, it doesn't really matter, you know.
There's a
Well, I
math
don't know.
club at my school, and it amazes me because I'm pretty sure I'm like
The smartest guy there.
one of the only math majors there. If anything, I feel like.
Oh,
if
is
anything,
it like
I'm
it's like a
the
math
smartest
fan
'cause I'm,
club?
like one of the only-
Or are they just like
I
trying
don't
to
even
hook?
know because
It's like a find math
they,
people
like,
hookup club.
mentioned the, like, oh, it's math club, and I'm like, where are all these people when I'm like showing up and signing up for analysis? I'm literally the only person in the class.
Oh, I
Like,
see.
where-
Wait, have you
where are
gone
these
to math club? Is math club like secretly
I
like
went there, like,
meth
once
club?
a day.
Oh no.
I theorized it because the teacher who runs it has some like wild stories about partying. I didn't realize it at the time.
It's secretly
'cause my
meth
friends
club.
had a Instagram group chat, and they called it LSD fishing trip. And it turns out, because that dude was my differential equations teacher,
Yeah.
he had been telling them one time in their calc course, he was just talking about like this one time that he went fishing on acid.
That sounds
In the
fun.
middle of calc.
I don't think I've ever
Yeah.
gone fishing on acid, but that sounds pretty dope.
It is a interesting story. He also he thinks that he might be related to the original founders of the Branch Davidians. It's not confirmed, but it's distinctly possible because he's from the same place that they're from, and the only difference in his last name is one H. So he theorizes that they had kind of just like added an H into their last name to try to make it seem less suspicious after the whole.
Oh,
Waco
I
incident.
see. Okay.
Dude, a bug just bit me on the back of my neck. Will I be
Nice.
Spider-Man now?
Okay. Let me
How's
let me
that
have
help?
let me have out Jack. I'm gonna skip the queue for a second just to help Jack out. Jack, by the way, if you want to like talk, do you know how to like join our
So-
Discord and stuff? That's how we talk on things here.
He's in here.
Where's Jack? Oh, Jack's in here. Oh yeah, get him up
I
here.
did Discord.
Hello.
Good job. What's up, Jack?
Hi. I just wanted to go over like question 6 from
I
the
got you,
final
bro.
you did.
Yeah,
today.
I got you this one. Okay,
'Cause
cool.
Technically, so this one was very similar to one I did with office hours with you.
Yes,
a few
very,
days
very similar.
back. I even had like the stuff you put on Campus Wire pulled up just to guide me.
Mhm.
And So my reasoning, I chose number B because one, it looked very similar to what we went over, but I knew this question was kind of different based off when I read it.
Well, I think
but-
there's 2 charges, right? Is the issue?
Oh well, in the other question there was 2 charges as well.
Oh, why is this one different then?
This one is only different because in last time, you didn't have 3 variables. You only had 2. The distance
Correct.
measured from
Gotcha.
negative charge to the origin, and then positive charge to the origin.
I put an offset on it. That's what I did. I have to remember sometimes.
An offset, yeah. And so what I was doing when I was working it out was, so technically, if
PCFG.
D is the distance between negative Q and positive Q, the spheres, and we can treat them as point charges in this case because of just the distance between them is so big, and they're conducting spheres. And that it says in the equation, I think like the radius of both spheres is so small compared to C and D.
Yeah,
So
for sure.
I had no problem getting through the first part of the calculus, but I thought my answer was correct because technically C is just posted as the distance from the negative Q charge to the origin. And technically, since D is some offset away from that negative Q, I was like, well, why don't I just do a thing where I just treat the distance between the negative charge and the positive charge D as my main variable I play with, because the distance. So on my paper I had RA from. All right, let me clarify. So A is the negative charge Q, and B is the positive charge Q plus. And I was.
A is the minus charge, right?
Yeah, A is minus, B is positive.
Okay, fine, cool.
And I was like, so I know there's a distance D between them. But it didn't tell me how big D was compared to C.
Sure.
So
we just know that they're both bigger, right? Yeah.
Yeah, they're both really big compared to the radius.
Okay.
But what I do know about C, it's from the very center of A all the way to the origin. So when I drew this out in my diagram, I was like, okay, I could work with C as an extra factor, but I was kind of having trouble with that. So I realized, why don't I just work with my other variable D? So what I did was the distance between, I just chose an arbitrary point along the line. Sorry, hold on. So what I did was I chose an arbitrary point between charge negative Q and Q. And then from there, I was like, well, hold on. If I'm just working with R being the distance from A to B, and then from B, RA is from A along the line somewhere, ending in D. And
Does it
then
have to end on
RB
D though? Because technically, you
it
want
doesn't have
to you want to find the current density at every point. So you don't want to restrict yourself to it being on D.
Well, whenever I was like imagining my coordinate system, I had the origin was like on the same, I guess, horizontal line as a and B, but it was like the origin was in the center, or like towards more the center between A and B, or the charges A and B. Yeah.
Okay.
And in my mind, I was like, okay, they don't have to be perfectly symmetric. They can be offset, probably. That's why I assumed if it were offset. And so what I did was, so this might be hard to describe. I'm bad at describing things.
That's okay.
I made up 2 variables. RA, which is the distance from
I agree with
the
RA.
center of
The center of A
and
to R.
some whatever arbitrary X I choose along that line of D.
Okay.
And then RB would be from the center of B to that same arbitrary X I chose across at that line.
Okay.
And so then I was
Along
like,
D.
hold on. RA, the vector RA,
Yeah.
plus the vector RB equals D.
Correct.
So then I was like, whoa, I could work with this way easier than trying to figure out however C works into it.
Sure.
So that's what I did. So I just decided to fix around my equation a little bit and had it basically look like R over, or sorry, it looked like the current density equaled KQ over P, then in parentheses, R over R3 plus D minus R over D minus R, parentheses, to the power 3. I thought that makes sense.
That only makes sense if you're only looking at the current density and it's a long D. That's the issue.
Oh,
We have to find the current density at every point in the surrounding space. So you can't talk about just being here, because you were saying that RA is pointing along D. Oh, thanks for the raid. Kitties, please, and yeah, what's up? 2 new people I've never heard of. Well, actually, I know N-Simplex. Sorry, my bad.
Yeah, I was gonna say. You know,
Yeah, I know. Yeah. Kitties, please. Thank you, Kitties, for the raid, though. Awesome. I'll check you out, Kitties, in a second. One second. Let me explain this. Okay, so yeah, you described RA as doing this, and then you described RB as doing this. Cool.
Yes.
The issue is that then assumes that R, which is where you're trying to find the whatever the electric field, is only along D.
Okay.
But it's not. The electric field, I want to figure out at all points in the surrounding space. So I need to figure out, for instance, if it's way out here. You were correct to do like some RA stuff. So in this case, if this was RA, let's call that. And then let's call this RB. Okay. Then I know my electric field, whatever, due to the -1, right?
Yeah.
So that would be minus, so E minus would be equal to K, negative KQ. And then, yeah, that's going to be over RA squared magnitude. And then that's like RA hat. And we know, right, the better way to write that is to say this is the same thing as RA vector over RA to the 3rd. And then E plus. Kitties came over to learn some pre-calc. We're doing good. We were doing, good to see you, Kitties. We did a little bit more advanced math stuff earlier on, but I help out with all sorts of levels of stuff. So this was partial differential equations. This was a crazy combinatorics question. And then this is I would say like a second semester physics college question. But Kitties, if you want to submit any sort of pre-calc question you want us to go over, here's the link for it. There's a website where you can put in your screenshot of whatever you want us to go over, and then we may do it. So check it out. All right. So, okay, this is the electric field due to the -1. Then this is going to be the electric field due to the +1. Yeah. This will be RB. So that now I need to express these vectors in terms of like R mainly, and like some other constants, right? Because RA and RB are going to be changing. So, looking at the diagram here, right? Do I see that R vector is equal to C plus RA, right?
Yeah.
Okay. And then how would I describe R vector in terms of RB?
C plus R. You would describe it as RB plus. All right. So sorry. Hold on. You're okay. You would describe it as RB plus.
I would start at the origin. Start at the origin, Jack. Right. Think about like I need to get from here to here. Right. What's my path? Do you see how I take C, then I take D, and then I take RB?
Oh, okay. I see now.
Okay. And then what I'm going to do here is I'm going to rearrange these for RA and RB.
Wait, is it okay for you to add R equals C plus D plus RB?
Because look, C, right, points from here to here. D,
oh, wait, sorry. I was thinking of geometry stuff. Yeah, no, it's vectors. You can do that.
Yeah, it's head to tail, head to tail, head to tail. You got it. So,
okay.
Yeah. So then this was C plus D plus RB. So RB is equal to R minus C minus D. And so now you can replace those in here. And so this would become KQ. It's all gonna be KQ on the bottom, or sorry, on the top. And then
I didn't know to have some origin some other place. I thought the origin was between RB and sorry, not RB and R, just A and B, the charges.
You assume the origin was here. You assume this was the origin.
The origin was somewhere on a horizontal line that had also A and B on it, and just the origin was somewhere in between them, because I didn't think the origin would be behind them.
It could be anywhere, honestly, but to me, it's just
an assumption.
Yeah. Whenever you have these cases of, like, in general, when they say, like, at every point, you have to throw out the window and any sort of, like, nice, simplified assumption that would make this question look easier, right?
Yeah.
Yeah. You just draw the most messed up base case you can get or something. And, wait. So this was C minus R. I want to make sure I get the right answer. Sorry. C minus R, that, and then it's plus RB. So this is R minus C minus D vector. All over 1 over R minus C minus D, all to the third. Which I think was this one. Yes. Someone pointed out, however, this one is technically also correct. Or actually, sorry, no.
I know.
Or this one. This one is technically also correct. Yeah, I screwed up when this is why it's hard for me to come up with like multiple choice, like 4 different multiple choice distractors. What I meant to do in this one was I meant to switch this. This should have been R minus C. But I screwed it up. So I had to accept both A and D for this.
All right. Do you mind if I take a picture of that real quick?
Oh, of course, dude. And I'll also... Okay, you're good. I'll also put this in the Discord is what I'll do. Here, I'll save this. This was Jack. Dr. Gold. Mr. Gold. What? Don't call me Mr. Gold. Mathematician, dude. My name is Dr. Gold. I did not go to grad school for 9 years to be called Mr.
Oh no.
Did not happen.
I know a friend who says they wanna go to grad school like purely so that like if they're ever in a bus or a airplane or something and people start yelling like, "Oh, is there a doctor here? Is there a doctor here?" She
they
can
could
be
just
like,
show up.
"Yeah, I'm a doctor." And you'll be like, "All right, help," and then she'll be like, "No, like I'm a doctor of English,
Oh no.
Yeah, that's so rude.
not a medical doctor."
I was on a flight actually, and they were asking for like, do we have a doctor on board? Because someone was having like an issue. I did not raise my call sign. I did not hit it. But I guess there was no medical doctor on board, because then they were like, okay, do we have a nurse? Silence. And then like 5 minutes later, they're like, do we have an EMT? Like, do we have anybody that has medical training? Like any sort of something? And I was about to be like, well, you know, if you turn the Wi-Fi on, maybe someone could hit ChatGPT for us.
Oh no.
Because we've
I
kind
don't
of
know why
gone
they would
through
like keep going that like, because I feel like if someone's an EMT or a nurse, they would still like step up like at the doctor question. And be
Yeah,
like,
yeah,
well, there's
yeah,
no
yeah.
doctor, but I mean, you know,
Yeah,
an
they're like,
EMT.
there's no medical doctor. Okay, is there a nurse? No, there's no nurse. There's an EMT? No, there's no EMT. You know, just going down the list.
To be fair though, like if I was
The
like
EMT
a nurse
probably had
or
the
an
best-
EMT on an airplane, I would probably just not say anything. I'd be
What, because they're like
"Fuck
Good
this,"
Samaritan
like-
laws or something?
I don't know. I would just probably assume that like, even though I'm qualified, like I don't have the backing of, you know.
I have a quick question. I
I
was working through another one of the questions on the final.
What's
I
up?
I can just like submit another one of them.
Yeah.
The questions for your thing. It's just,
Yeah, just
for
do it.
question number 8.
Yeah.
I'll send you the screenshot or whatever. I followed the steps exactly on the solution guide,
Uh-huh.
and I am not getting the answer Kudu is asking for.
Okay. What about oh, I mean, you plugged it into the numbers like in the solutions manual?
I plugged the number using the numbers I was given in the final equations. Like I checked all the steps for question 8. I got with the numbers I was given on my Kudu question. I got the correct time constant. I got the correct initial current. I got the correct final current, assuming the one Kudu gave me was the one I'm supposed to use. and I even had the equation set up correctly, and I'm not getting the answer.
How far is it off?
It is off by a factor of 3.
Oh, that's quite bad. Yeah, just submit it. I'll run through it. Just submit it as a screenshot.
All right, give me a second.
You're
Gotta
good.
pull it up.
But yes, kitties, what's up? Welcome to the stream, kitties, please. Let's go find out who you are. Sorry, I want to go shout you out, kitties. Kitties, please. Gotta be careful about putting that into Google Images. Kitties, please. Kitties, please. Nice. You love learning. That's great. I love learning too. I'm gonna give you a follow. Hell yeah. Love learning, kitties. Kitties, please. Oh, you have cats on your stream. You have to have cats on your stream. Of course.
Section in the Discord.
Oh, he's so cute. Oh, I love. What do they call these? Like a tabby cat? A ginger cat? What are these cats called? This is adorable.
Fat one.
A fat one, a chonker.
You done messed up, AA.
No, he's so cat. He, she, whatever is so cute. That is such a cute cat. Oh, that's adorable. But yes, welcome kitties to the stream. My name's Dr. Gold. This is Actual Education. We're a nonprofit, so what we do is we have like kind of a live office hours that anyone watching on we're on YouTube, we're on TikTok, we're on Discord, we're on Twitch, can submit a screenshot of some homework question or something that didn't make sense in their class. And as long as it's something math or science related from middle school up through like early college, we can help you out. And it's kind of like a fun little game talk show type thing.
Gotta be careful. You gotta clarify. Otherwise, they're gonna start submitting JE.
Yeah, but no JEE questions. Sorry, yeah, don't do it. We don't like JEE questions.
Sorry, sir. No JEE questions.
No JEE questions, Sar. I'm sorry, dude. Friend-shaped. Yes. Friend-shaped. It's not a chonker cat, dude. It's a friend-shaped cat. That's cute. Have you attached any lasers to any sharks? The sharks need frickin' laser beams.
I put it in the queue.
Perfect. Do you know how to upvote too? So yeah, let me show you people how this works as well. So
yeah, I upvoted.
Great, good. Yes. So when you put a question into the queue, it gets like kind of a ranking based on how long it's been there for, what the difficulty level is. This is hilarious, Breasticles, because this is false, dude. You've been farming this off a level. This is not a level 2 question.
I have been farming it.
Yes. This is wart. Yes. Wart. But yeah, you can also upvote your question every 3 minutes, I think, to like boost it to the front. So in the spirit of gambling, our favorite thing, let's go pick a winner for our next question.
Let's go gambling!
Who's it gonna be? Probably gonna be Breasticles. If it's not, that'd be crazy. Okay. Okay, cool. All right. Pseudo inverse. So Breasticles submitted just a screenshot of a matrix. So the
yeah, that was in fairness. That was all that was written on my screen. It was
the auto difficulty app said it's not very difficult, but okay. What do you want me to do with this matrix?
It's actually not like a crazy difficult problem. We're gonna
are we gonna find the inverse of it?
SVD.
Can you find the inverse of a non-square matrix? Is that possible?
Well, so what we do is obviously not every matrix is invertible, but we have what's called the Moore-Penrose pseudo inverse. And
pseudo inverse.
It's pretty much a generalization / approximation of the inverse of the matrix. And we can find a pseudo inverse for any matrix, but an actual inverse, we can't get that for every matrix.
So what a real inverse matrix does is, so matrix, for those that may not be knowledgeable of like what matrices are, matrices are just collections of numbers. It's like storing a bunch of data in something. And if you take a matrix, this is what we say, like a matrix A, and you multiply it by its inverse, you should get what's called like the identity matrix, which just basically looks like this if it was a 2x2. And this is the identity matrix, which is a bunch of diagonal ones and off diagonal zeros. What's up, Zach? Another very cool streamer, Zach. We love Zach. So and again, this also applies to kind of just regular numbers, not even matrices. Let's say, for instance, you had a number 5, and you multiplied it by 5 inverse. I know someone's gonna get mad at me. You're like, where's Zach to get mad at me for doing this? But this is the same thing as saying like 1 over 5. And notice if you multiply 5 by 1 over 5, you get just 1. So I like to say that inverses, when they act on things, kind of they give you 1. Oh, it's perfectly acceptable. Oh, nice.
My name is Jeff.
Where's my jet? Where is it?
By mathematical authority, this is bequeathed upon you that you may break up the DRDT.
Thank you, Zach. I have been bequeathed upon me. Okay. So yeah. So explain to me, Breskles, because an inverse for matrices usually only works on square things, so that I can get like a square ones and zeros. What would a pseudo inverse give me?
Pretty much just another inverse, right? It's the same kind of properties of that we can multiply, right, and get an identity matrix.
How can I get an identity matrix if something's not square though?
I'd have to look back exactly in my notes.
Oh, okay. I'm just curious.
But I mean, the whole idea is that like real world, like if you're doing like machine learning or whatever, a lot of your matrices aren't actually going to work out cleanly.
Sure.
And be easily invertible. And so we have like different ways of coming up with pseudo inverses for things like least squares methods. And generally a way to like get there is we use pseudo inverses to basically say, this is a generalized,
like close enough.
Yeah, like this is pretty much the inverse, and it's not exactly like A times A inverse is going to get you I, but you get to I.
Guaranteed squareness. Yeah, A transform A will also, guaranteed get you a square matrix. Because in that case, I think what you do is, right, you multiply, like, if something was like a 3 by 4, and you're multiplying it by a 4 by 3, then you're guaranteed to get a 3 by 3 out of it. Because exactly. As long as these things match up, you can. So if this was A and this was like A transform, and then the resulting matrix is a 3 by 3. Okay.
Yeah.
All right.
This extends to like differential operators and stuff like that too. So like if we consider a matrix like a transformation, right, on a vector, in that same way we can do similar with a like a derivative operator to come up with like a pseudo inverse of a derivative operator, which we do in things like Green's functions, to come up with an inverse operator to solve certain equations, right? Because if we had like, with the matrices, if AX equals B, if we know A inverse, we can just say that, well, X is going to be equal to A inverse B.
Yeah, I agree with this. And this is, again, this goes back to, again, very simple algebra. Say, for instance, again, you had like 5x is equal to 10. How do I solve for x? I divide by 5. The other way I could say that is I'm multiplying by 1 over 5. Or you could say I'm multiplying by 5 inverse. And then notice how 5 inverse cancels this to become 1. And you just get x is equal to 1 over 5 times 10. And that's also equal to 2. Wow, very cool. We also do it with trig. If you have, for instance, like sine of x is equal to 1/2, how do you get rid of the sine? We multiply by sine inverse, or you like act sine inverse on both sides. These cancel out to become like kind of like 1, and you get that x is equal to that. Yeah. So inverse things are really, really cool. I get why we need them. Okay, but how do I do it on this one?
So we're going to use what's called singular value decomposition.
SVD.
And it's basically a method that we use. You're pretty much doing a rotation, scaling it, and then doing another rotation.
Okay. Yeah, if you like video games, matrices are a big thing with coordinate systems and all sorts of position things. Vectors are like for
this
light
method is-
reflections.
Yeah, this method's pretty big, and it gets used a lot in like machine learning math.
Machine learning, okay, cool. If you want to go develop some
and
AI
machine
stuff,
learning, this is
learn how this stuff works. Right multiplication and left multiplication. Those two things are different. I agree. Okay, but how do I do SVD? What's the trick?
So we're gonna want to find a couple matrices. The whole idea of it is that we're gonna get A is equal to U sigma V transpose, and then we're gonna get our A asterisk is gonna be V sigma asterisk U transpose, and that asterisk is the what's it called?
Wait, U sigma transpose? Sorry.
No, sigma U transpose.
Sigma U transpose.
Not capital sigma.
What's oh.
Yeah, that's lambda. No, the sigma notation for like a.
Oh, sigma. Oh, dude, what am I saying?
Yeah.
Jesus. Okay, sigma U transpose. And then wait, sorry, what was the first thing you said? Did I put sigma instead of lambda?
Yeah, it should be sigma, not lambda, and then there's a V transpose at the end there.
Okay, there you go. That's what we're saying.
Those asterisks, and the asterisks are conjugate transposes, right? So like it doesn't really matter for us since it's a real matrix, right? So it just becomes a transpose. But if you had a complex matrix, it would just be the conjugate as well.
Mm-hmm.
So we're gonna our first goal is that we want to find A transpose A.
Okay, let's figure out A transpose A. So that's gonna be, from what I remember, you switch the rows and the columns. So I think this becomes -1, 1, 3, 3, 1, -1. Did I do that right?
No, it should be 3, 1, -1, and then -1, 1, 3. You don't like swap the positions. You pretty much just like literally like rotate the matrix 90 degrees.
Well, I thought I did. Didn't I? You rotate it 90 degrees clockwise or counterclockwise?
Counterclockwise. Sorry, I had to think about that.
Okay, so if I rotate it counterclockwise, doesn't this like go on the bottom left? This is now the top.
Right. Sorry, hold up. Did
I do that right?
To think. Pretty much just you would go down your first column and then you would write all your entries to the right. And then
this becomes the first row?
Yeah. I was trying to think of that in my head.
Oh, so this is 3, 1, -1. And then it's the next one?
Mm-hmm.
And then it's -1, 1, 3?
Yeah.
Oh, yeah, that's very much not a rotation.
Yeah, it's a rotation if you think of it row-wise, and I was thinking row-wise like when I said that. And then I was
I see. Well, that way
you
you're
would
doing
do
it
a
clockwise.
Counterclockwise rotation of the row. So like if you held it at 3 and then you rotated 90 degrees
Clockwise. It would be 90 degrees clockwise, though, no?
No, it would be counterclockwise.
Well, I thought this needs to go on the bottom.
I mean like each column. Each column you would do that, and then that would be its...
Oh, okay.
Yeah.
Got you.
It's a row.
Okay, whatever. All right.
Made sense in my head.
Oh no.
Okay, so we get to this, and I gotta go multiply that, which is kind of a pain, but yeah. All right, so
you get 11, -5, -5, 11.
Okay.
So
11, -5, -5, 11.
Yeah.
Okay, cool. How I get that, just to show people real quick, is this times this, but you do this times this, so that's like 3 times 3, and then you do plus 1 times 1, and then you do plus -1 times -1. I think we're coming back. There we go. There we go. Okay.
It's 2 Dr. Golds and
Why are there 2?
Dr. Gold and Dr. Gold.
Oh, man. There we go. Okay. Back, yeah? Yes? No? Maybe so?
Yeah, I hear you.
Okay.
I don't see anything, but
One sec. We're coming back. Coming back. You know what's super weird? All right, so I have 2 internet connections, by the way. So I run the Twitch, the Discord, and the YouTube through like Spectrum. I run TikTok and everything else through T-Mobile, and they're on like 2 completely different lines. I think the power in my entire apartment just dipped for like a second, and it triggered both of them. No, we're here.
yeah, I think that's the only like logical explanation.
That's super weird, because also one of my monitors flickered on and off. And I was like, wait, what? How did that happen?
Yeah, that's probably it.
That's crazy. Okay, sorry, let me go back to this
Actually,
question.
I just got a red alert just after you disappeared.
What was a red alert? What was a red alert? What happened?
Worldwide outage, just instantaneously across the entire face of the Earth.
Stop it, dude.
My power was fine.
Wait, you really? Is this true? Is this true, dude? Are you trolling me, dude?
No, I'm staring at my route right now and it's sitting there complaining.
You know what's a great one? Down Detector usually has great stuff. Let's see if Down Detector had a spike on everything. I'm actually really curious about that. 4chan.
Fortunes.
Wait, can you send me the link to the thing that says there was something that went down everywhere? Wait, what?
I feel like this is a troll.
No, well, no, there was. Well, that was at 5 o'clock. That was a long time ago. No.
It's just a piece of software that I'm running. I can't send you in.
Oh, okay. All right, whatever. Okay, we're back.
My power was fine. My Wi-Fi was fine.
It could have been a coronal mass ejection, dude. Maybe we had a CME that hit or something. One sec. Actually, I want to check out Inspector real quick, because I want to see. Because I'm getting subpar frames in as well. Whatever. Authorize. Yeah, there we go. Yeah, this just.
Oh shit, not good.
Just died. But then I don't think I'm getting great frames right now, anyways. Oh, we're okay. That's still pretty low. 5K? Usually I'm pulling, yeah, like 7. Okay. I don't know. All right, let's get back to the question. The show goes on. All right. 9 plus 2, right? This was equal to 11. And that's how we got this. Because it's the top left element. Okay, great, cool. Curious if anybody else in LA like experienced like that slight blip in the power. It's kind of weird. I should post on Insta as well. Yeah. I've tried streaming on Instagram. It doesn't do too well. Okay. All right, so once I get to here, A transpose A, yeah. What do I do with this afterwards?
But so this stream is tweaking for me.
Is it? Oh no.
Yeah. But you want to find the eigenvalues of A transpose A.
Okay. It's coming back. I see. No, actually no, dude. My bandwidth is all over the place. Sometimes it's, yeah. Now it's like really hampered. Oh man. Something probably just screwed up.
Everything's fucking screwed up.
Okay.
Let's
Yeah, you're good, Jack. All right. So 11 minus lambda, minus 5, minus 5, 11 minus lambda. And we do the determinant of this is equal to 0. So I'm going to get 11 minus lambda squared plus 5. Or no, minus 5, sorry. Is equal to 0. Also, wait, what happened to my... Why is my countdown not working? The hell? Oh, alright. I got a lot of things just went down for some reason. I've also noticed something weird where I'm getting like signed out of a lot of my things. Has anyone else noticed that? Like I had to re-sign into a bunch of apps today. It's kind of weird.
I don't think I've had that happen.
Yeah. I don't know if it's like a coincidence or something, but I know you'll get like logged out of things occasionally, but yeah, I did have like everything. There's a lot of like my fitness tracker or whatever was like, you need to log in again. I'm like, huh? And I had to sign back into my WhatsApp today as well, and it said I was on a new device. Dude, maybe Palantir's coming after me now, dude.
Oh no.
Like they know we're giving off too much
Probably
knowledge.
Sensation's fault.
Sensation, dude. What did you do, man?
To whom?
To whom, he says. Okay, so 121 minus 22 lambda plus lambda squared minus 5 is equal to 0. I don't feel like these are going to be nice eigenvalues.
It could be minus 25.
Yes,
So
you are
that
right. It is
was-
minus 25.
yeah.
Yes, because it was these two things multiplied by each other. Correct. Okay.
So I'm gonna leave real quick and try rejoining, see if this stream link should pop up on Discord.
All right. Yeah. All right. Here, I can stop streaming it. Stream it again. Let me try. Give me a second.
I was just seeing the like.
Oh, dude, what? Why is it
squares.
streaming my horizontal now? The hell? Wait, 1 sec. Dude, what is going on today? There we go. Okay.
So I guess it might be a software, like a virus from the Kudu devs, or like.
Oh no.
Like calling them on their shit. Like, take this virus.
Yeah, I'm also dropping 80% of my frames. Ugh, it's a pain. Whatever. Okay. This will probably be the last question. I'm gonna stop, just because I don't want to deal with any more technical issues right now. Okay, lambda squared minus 22 lambda. 121 minus 25 is that 96?
Yeah.
What factors of 96? Subtract
It
to...
goes to lambda minus 16 and lambda minus 6.
Yes. That is correct. Okay. Cool. So lambda equals 16 or 6?
Mm-hmm.
All right.
And then we're gonna say that our sigma 1 and sigma 2, these are little sigmas, it's gonna be 4 and root 6.
Say that again.
So sigma 1 and the lowercase sigmas are gonna be the square roots of these, because we have what the sigma is called our singular matrix, and it's
so
gonna
this
be,
is not a sum. This is an actual thing.
yeah, that's a matrix. We call those the singular values,
Oh.
which are the square roots of our eigenvalues. And those values, we call them sigma. And
Okay,
so
so
we
I'm
call them the lowercase sigma and then uppercase sigma for the what's it called? Uppercase sigma for the actual matrix itself.
Okay. So lowercase sigma. Oh, I gotta, dude. What is?
It's
Is
the
this-
like little circle with the.
This is sigma, right?
that one.
Yeah, right. I was like, forgetting. Okay, so this is equal to the square root of 16. And okay, it's equal to 6, yeah? Or square root of 6, sorry.
Yep.
Okay. And then what?
Then we want to find our eigenvectors, which is going to be our V matrix.
Ooh, okay.
So we want to find the eigenvectors for those two eigenvalues.
And this is times, like, whatever, this is V1. I forget, does this have to equal 0?
Yeah, that would equal a zero, or not the zero matrix, a zero vector.
Yeah, okay, that's right. So that tells me, oh, so if this is x1, x2, that tells me 5x1 minus 5x2 equals 0. Okay, cool. So then, and then also negative 5x1 minus 5x2 is equal to 0. So it just tells me x1 equals x2?
Yep.
That doesn't really work for this, though.
Yeah, it does.
Negative 5 minus 5. Negative 5 minus 5 is negative 10. I fuck up somewhere?
You should...
Right?
Let me look. Oh, sorry. You should get x equals negative, or x1 equals negative x2. Because you
How do I
should
get that
have,
with
you'll have,
how do I get that with the top one, though?
because you have 5x1 minus 5x2.
Equals 0, right? So that tells you x1 equals x2, no?
Oh wait, sorry. So that explains a lot. Sorry, I was.
I think this thing you gave me is wrong.
No. So what happened is when you use the eigenvalue of 16, you get the matrix negative 5, negative 5, negative 5, negative 5, and then when you use the eigenvalue of 6, you get 5, negative 5, negative 5, 5, and I was looking at the eigenvalue or the eigenvectors.
Oh, okay. For the first one.
Yeah, for
sorry, yeah, I did it for 6. I don't know. I don't know if it makes sense for 6. Unless I'm just like not getting something. Oh, it's because it's plus.
Oh, you put an extra negative.
Oh no!
Oh, I'm so stupid. Yes, x1 equals x2.
Mhm.
Okay, and then whatever, we're going to say x1 equals negative x2. For lambda equals 16. So then your eigenvectors are 1, 1. Or I'm going to say negative 1, 1. Yeah.
Mhm. And then one other thing we want to do is we want to make them orthonormal, so we want to divide by a root 2.
Okay.
Just to normalize that.
Yeah, okay. Okay. All right, what do I do with those then?
So now we just want to find our matrix U, right? So we're going to say that UI is going to be A VI over sigma I. My handwriting's pretty bad, so I couldn't tell if it was a sigma.
Oh no!
Wow, you can't even read your own handwriting, dude, dog. Big dog, bro.
Normally I can, but the
no, dude.
tail was a bit too curly on the sigma, so it started looking like my
Okay. Sorry, it's UVI over sigma I?
Mhm.
Okay.
And then we just want to plug in for the 1 and the 2.
The 1 and the 2, he says.
Yeah, for our eigenvalues, right? Because we have sigma 1 and sigma 2.
Oh. And sigma's the square root thing? Or no? Wait, sigma's the eigenvector? Or...
No, sigma is going to end up being a matrix. It's a lowercase sigma.
This is the lowercase. Okay.
So that would be like sigma 1 or sigma 2.
Okay. So, A was this thing. Okay. And then VI is my eigenvector, right?
Yeah, and in this case, you use the ones this time.
Oh, now we're going to use the ones?
All over the place. Yeah, it
just
depends. You could write it as like VI. Inevitably, you want VI to be normalized. But it just depends on how you write the formula.
Okay, and then this is over 6 or square root of 6?
Square root of it.
Okay. Well, this is a mess.
Yeah, at this point I plugged it into a computer. You'll get 1 over 4 root 2. Let me make sure I'm looking at the... Yeah, okay.
And I should get a 3 by 1, right?
Yeah, and you'll get 404.
404, he says.
Oh, no.
Okay. Cool. And then I gotta do it for the other one.
Wait, sorry, hold up. I'm making sure I wrote my work correctly. That's for the eigenvalue for 16. Sorry, that's...
Oh, okay.
So it should be... The matrix itself should have a... Sorry, that one's going to be 1 over 2 root 3, and then 2, 2, 2.
2, 2, 2. Okay.
And then we need to find a U3 to save you the effort of it. So basically you want it to be orthogonal, right? So you want the dot product of U3 and U2 to be 0, and the dot product of U3 and U2 to be 1. And that's going to give you a system of equations that you can solve for U3.
So U3 is equal to some U1 cross U2, yeah? But then I also need it to be orthonormal, sorry?
So we want U3 to be orthogonal to our U1 and our U2.
So I have the cross product of U1 and U2.
3 by 3.
Right.
Yeah, cross product should, yeah. I did it as a dot product, but it shouldn't matter. And then at the end of that, you'll get 1 over root 6, and then 1, negative 2, 1.
1 over root 6, and then what?
1, negative 2, 1.
Mathematician says, I cannot see what you're writing. Why can you not see what I'm writing? It's pretty apparent, dude. Maybe it's not thick enough. You can make it thicker. Okay. Cool. So now I have U1, U2, U3. Right? These 3 things.
And so our total matrix U is just going to be those vectors as each column.
Oh, okay. So I have to include all the stuff in though, right? I have to include the multipliers. Right? So this is going to be
yes.
Well, I guess yeah, okay. You called U1.
You could just...
Does the order really matter?
Like that. I think so. I want to say it does. I think as long as you're consistent with what's what, U1 and U2 would need to be coming from the actual like eigenvalues. And then U3 would just kind of be chosen. I didn't even like write it in. I literally just wrote like U1, U2, U3, and I just plugged it all into a computer to solve it later. And then we want our sigma matrix is going to be a 3 by 2.
What's
and
that
that's
look like?
just going to be, so our first, like our diagonals on that top 2x2 are going to be our corresponding, right? Our singular values, our sigmas, and then the rest are zeros.
Top diagonal. Sorry. So right here.
Yeah. So in our 1-1 and our 2-2 spot, they're going to be our corresponding sigma values.
Oh, so square root of 16, square root of 6. Then 0, 0. And then what happens over here?
It's 0, 0 on the bottom row.
Oh, right. Sorry, it's a 3x2. Yeah. Okay.
And then from here, you would multiply your V, our sigma, sigma adjoint, and then U transpose, which is just like a bunch of matrix multiplication. And you would get 1 over 24 and 7, 4, 1, 1, 4, 7.
Okay. So wait. So what's my final answer?
That 1 over 24.
Yeah.
And then 7, 4, 1, and then 1, 4, 7.
Nice. Okay, cool. And this represents my pseudo inverse.
Mm-hmm.
Cool. Looks fucking weird, but I guess yeah, sure. I don't really know what it does, but it looks cool. I like that it's a bunch of nice numbers.
I want to say that but it should be when you multiply that by your original matrix, you should just get the identity.
How can I get the identity though for a 3x2?
Because you're multiplying by a 2x3. So you would get an identity matrix there. That's kind of the idea, is that even though it's not yeah, see, because it's, even though it's not technically an
inverse.
What's it called? Yeah, it's not like technically invertible, but we can generate something that works like an inverse for us for our applications, and then
that's
still
super
gives
cool.
us that same identity property that we would look for.
Okay, that's cool. Right. Okay, so we're saying. Wait, this times this would still get me 1, 1, 1, 0, 0, 0, 0, 0, 0.
I believe so.
That's cool. Dude, my question, I beg you. I told you, I don't do Math Olympiad questions, mathematician.
Oh no.
Alright, cool. Let's close that stream. Alright, thank you everyone for coming to Education Office Hours. Appreciate all the questions. I do like kind of set a timer on these things, because otherwise, dude, I'd be here forever. So, we did 2 hours today. I apologize for the technical difficulties. I don't know. All the electricity in my house went out for like 5 seconds and wrecked shit. But that being said, I still plan on having office hours tomorrow. So, oh, did it work out?
Yeah,
oh, cool. Yeah, 24.
And then there's the 1 over 24, but yeah.
Oh, sorry. Yeah, no, sorry. It would be a 2x2. It would be a 2x2 though. You're right.
Yeah. Well, I think I was the one that said 3x3.
Whatever. Yeah. Yeah, it's 3x2 by 2, but it's 3 by 2. Wait, no. There are 3 rows. Shouldn't you get a 3 by 3?
3 by 2.
Oh, you multiplied it the other way. You did it the other way.
Yeah, it depends. Yeah, it depends on if you're figuring out a right inverse or a left inverse.
I see. Okay. Got you. But yeah, let me mark that one as done.
This one would be a left inverse, because like if we wanted a
I got you. Yeah.
system of equations, and we want the left inverse to solve it.
Yeah. Okay, so we will still have office hours, I think, tomorrow. I'm pretty sure we'll have them tomorrow. Again, always check. This will be the most up-to-date schedule, actualofficehours.com. That'll tell you whenever I'm streaming. If sometimes I have other work meetings and things I gotta take care of, so I gotta like shift the schedule around. But for now, I'm planning on being here at 6 o'clock tomorrow. So come by if you got any questions. If we didn't get to your question today, we'll get to it tomorrow. Or what happens is every time we do a question, or anytime you submit a question, these all get put into our Discord, and then the bot will sometimes go through and just solve them. So look out for those. Cool. All right. Appreciate that. Let's go raid somebody else. Let's go say hi to someone else on Twitch. Who do I want to go say hi to? I appreciate the raid today. We had a raid from Obi and Kitties Please. Very cool. Dr. Gold, you should do a POD system in the server with different subjects. Oh, problem of the day? Yeah, we used to have that. It's just, yeah, we have such a spectrum of like math competency in the server that it gets hard for me to like pick one thing. Yeah, why'd I remove it? Because it wasn't really being used, I guess. I don't know. Anyways, I only got 2 people on Twitch anyways. Go say hi to High Potential. He's a fun guy. Oh, I can't raid? Okay, whatever. I guess we're not gonna raid anyone. Anyways, okay, fine. All right. Enjoy the rest of your Monday. We'll see you on Tuesday. Peace.